So part A is asking us for the velocity of the water as it enters the pail, and then part B is asking us how long it would take for this sink to empty out. So A, the cross-sectional area will be 38 centimeters squared, and then we have a change in height between the sink and the pail. So this is going to be 85 minus 45 plus 4, and this is going to be this is in terms of centimeters. So we can say that this is going to be 0.36 meters. We know that diameter is going to be 2.3 centimeters, which means that radius is going to be 0.115, or rather 0.0115, my apologies. And we're going to say that V sink is going to be 0 meters per second. So let's apply Bernoulli's equation. So P of the sink plus half rho density V sink squared plus the density times G times Y of the sink equals equals pressure of the pail plus 1/2 density V of the pail squared plus PGY of the pail. So we can eliminate some of these variables. This is going to be equal to this, so they are both going to cancel out since they're on either side. We know that the velocity of the sink is going to be 0, so this is eliminated, and we can now solve for the velocity of the pail here. So the velocity of the pail is simply equal to 2g y sink minus y pail to the 1/2 power. And we can say 2 times 9.8 times 0.36 to the 1/2 power. And the velocity as it's coming out of the pail is going to be equal to 2.66 meters per second. So this will be our answer for part A. And then part B is asking us how long will it take for the sink to empty. So we can say that the volumetric flow rate of the pail is going to be equal, rather, the volumetric flow rate of the pail is going to be equal to the volume of the sink divided by time, which means that the volume of the sink simply equals T times the volumetric flow rate of the pail. And at this point, we know that the velocity of the sink is going to equal the area times the height of the sink. And here, height of the sink is going to equal 4 centimeters or 0.04 meters. That's automatically convert from centimeters to meters. So we can solve for T, and we can say that T is going to be equal to the velocity of the sink over AV of the pail, the volumetric flow rate of the pail, and this is going to be equal to 0.38 the cross-sectional area times the depth of the sink, 0.04 meters, divided by the pi, 0.115 squared, so A would equal pi r squared. And then we'll multiply this by the speed of the pail, 2.66 meters per second, that we found in part A. And we find that this is going to be equal to 13.8 seconds to empty sink. This is your answer for part B. And that's the end of the solution. Thank you for watching.